All right. So first thing we need to do is in the React starter in the terminal, you should be on whatever branch you use to do the challenge. So I want you to go ahead and add commit and push it to GitHub. And then we're going to switch back to our master branch again. Once again, so we can start from a clean slate. Just as a side note, this isn't something you would do in a normal project. We're just doing it so we could keep starting over fresh without having to keep, npm installing everything and starting a whole project over again every time. So I was on the branch where we did the live lecture. All the steps are going to be the same. You're on a different branch, but the steps are still the same. Status, make sure everything is copacetic. Add, git, commit. For you guys, your commit message would probably be something like completed functional component challenge. I'm going to say completed functional components demo. And then once everything's been added, committed, and pushed, I am going to switch back to master. So git checkout master. And then once on the master branch, now you can switch to a new branch, and we'll call that new branch. We'll say git checkout -b class -components. If you stopped your server to do these commands or for any other reason, make sure you restart your server again. If you left it running, that is also okay. npm start to start the server. And then I'm going to go to my browser. And you should be back to the original starting point. And if you closed your code editor for some weird reason, reopen your code editor back to the React starter. Bless you.
Thank you.
Does anybody still need a minute to get to this point? Code editor open to React starter, dev server running, ready to go. On a new branch, all that fun stuff. All good?
Yes.
You guys have to be one of the best classes at following directions. My mind is literally blown. Either that or a couple of you are lying to me constantly. I don't know which one it is yet. All right. So we've learned about functional components. And what you've learned, there's really not that much more to them than what you saw. Of course, there's always a little bit more, but the meat and potatoes of it is exactly what you saw. A function component is a function, single parameter called props, and returns some JSX. One thing I did forget to mention, two things actually. One, once props is passed to you and you're inside your functional component, you don't change props, okay? It goes off of this theory of everything in React is a pure function, meaning you never change anything that's passed to you. Okay. If for whatever reason you needed to change some value that was passed to you, or let's say if a number was passed to you and you needed to multiply it by some other number, you could do that. You would just save it into a new variable. You don't ever directly change that props object. Okay. And like I said, that goes back to the concept of pure functions. Pure functions do not change their input. There's a little example in the slides. Sorry, guys. I literally just remembered when I started talking about class components about this part. Okay. So, and this is the whole pure function idea or paradigm is a common thing in just development as a whole. Okay, keeping your functions pure gives you more reliable output each time. Okay, take these two simple as possible examples of this is a pure function. We take in two values, we return the value of them being added together, but we never change x and we never change y. We're not changing anything that's passed to us. So every time we pass this function 5 and 5, we're going to get 10 100% of the time. It's never going to change. There's nothing that could possibly cause it to have any different output. So it is 100% predictable what's going to happen with that function. Whereas with the withdrawal example, we're passing in an account object and an amount to subtract from that account object. So here we are directly changing account.total. So if we call this function again and pass it that same account object, we're going to get a different outcome each time, which makes it less predictable, more prone for bugs and errors and stuff like that. So all of React, you're going to hear it over and over again with different stuff in React about how everything is a pure function. We never change the information passed into us. Okay? And where that directly relates to React and what we're doing right this second is that props object that is passed to us. We never change it in any way, shape, or form. We never add, change a property value. We never add a property to it. We never delete a property. The information that is passed to you is the information that's passed to you. And that is it. That makes sense? Cool. And like I said, you're going to hear this come up again and again. The one other small thing is that in the example, we make a function that gets props. And then we use props.name. Now, I need you to think of this outside of React. Does it matter what the parameter name is? No. It doesn't. Okay? And it doesn't here in React either. React doesn't know. It's just calling a function and passing it an object. It has no idea what variable name you used here. Okay? However, you should always call it props. That's the standard for React, but it doesn't matter in this case. And that's going to be important for what we're about to talk about, which is what made me think of it in the first place. All right? All right, so moving on to class components. And keep this open. Just so I could reference it, just to make sure I don't forget anything. All right. So we're going to go a little bit off the script of the slides. We're going to do something. I guess the slides actually have what we're about to do. Never mind. I lied. So first thing we're going to do is recreate the greeting component, but as a class component. So you can see something that you're already familiar with built as a class component. So first thing we do when making a new component, make a new file for it. So inside of the components folder, new file, and we'll call it greeting.js. All right. So in a functional component, what was the first line we did?
Import React from React.
Import React from React. So there's going to be a slight change to that now. So we're going to import React, and then we're going to do comma, curly brackets, component with a capital C from React. All right, so that's the first difference. All right, and then the next most obvious difference is that it's made with a class instead of a function. So we'll say class greeting, and then extends component. Okay, so what we're doing is component is a predefined class somewhere in the React library. We are extending that predefined class so we could gain all of the benefits and functionality that that component class has. And then we're adding our own functionality on top of that. Okay? There is one method and one method only that a React class component must have. And that one method is render. So I'm going to ask you guys down the road, what is the one and only method that a class component has to have? And the answer is render, not constructor. It does not have to have a constructor. Okay? People love saying constructor. I think just me saying constructor now messes people up down the road. Maybe. All right, whatever the render method returns is what is going to show up on the screen. So return, and sticking to our previous example, h1, hello, welcome to our site. And then just like a functional component is intended to be used someplace else, we're just defining it here. So we need to export default greeting. All right, so that is enough for it to work. All right. Now, just as a caveat or a heads up, if you write a class component like this, you're wasting a class component. This could have very easily been a functional component. You're not doing anything extra with it. And we'll talk about the extra stuff you can do with class components. But if you're just trying to render some DOM elements with some text in them that's static and not really going to change, you should be using a functional component. If you need more functionality, like stuff that's going to update and change, we'll talk about that very shortly, then you need a class component. We'll circle back around to that one though. All right, so now that we have our component built to the point where we could test it, we will jump over to app.js. Does anybody need a second here still? Inside of app.js, I will delete the h1 and the image. I will import greeting from this directory greeting. and then utilize my component. So on this side of things, when you're using a class component, it's the exact same as a functional component. Like if you couldn't see the file, you wouldn't know the difference between a class and a functional component when you're actually, like I said, utilizing it, when you're using it. From this side of things, it all looks the same. All right, make sure you save everything. Take a quick glance at your browser. Make sure nothing blew up. Make sure you actually see the text from your greeting component. You should see something along those lines. Your text may vary. Yes, sir.
So render is automatically called?
Yes. Very good question. Yep, render is automatically called. And there's an order in which certain things happen, and we'll get to that very shortly. But render is automatically called, and it is most likely to be called more than once. When the component first loads, it is called initially, and then as we start making changes, it will be called again to render those updates. We'll get to all that in the very near future. Everyone good? Everyone get their class greeting component to show up okay? All right. So one thing we did with our greeting component is we had it greet a specific person. So we'll do the same thing here. We'll pass a name into it. We'll say name equals some name. And now that isn't going to make it just automatically show a name now. We have to tell it to utilize that information being passed into it. So once you've added a name on this end, we'll use it inside of our class component. So one thing that is different with a class component is where the props are located. So console.log greeting props. They are located on a property of the class. So because they're located on a property of the class, how do you access properties of a class? This. So this dot prop. And this is this dot props because it's made up component creates this object. So it's always this dot props. Whereas in a functional component, if you really wanted to, you could change the parameter name and use something different. Once again, you shouldn't, but you could. Here, it's this dot props, no substitutions. Because this dot props, that object is actually set up in the original component class that we are extending. But other than that, the props work the exact same way. Okay? Any key value pair that you pass in when you actually utilize your component, so any key value pair will show up as an object at this dot props. Okay? Everything works the exact same. However many key value pairs you put on it, that's how many key value pairs are going to show up in your props object. So if we wanted to display the name, right after our hello, we could use our JavaScript expression and say this dot props dot name. Everyone good? So like I said, other than accessing it through this, everything else is the same. Nothing else has changed. Any key value pair gets added to the this.props object. So quick test, you should see hello, whoever's name you put, welcome to our site. All right, so all of this we could have still done with a functional component, obviously, because we already did it with a functional component. There's two main benefits you get from a class component. One big benefit is you get access to what are called lifecycle methods. Okay? So sometimes you need access to know when the component was added to the DOM, or you need to know when the component updated. Okay? If the value of name changed in the app component and a different value was then passed in, that would cause render to be called again. So if your props change, your component re-renders. This is an update. Okay, so there's a lifecycle method to get access to when that event happens. Most commonly, though, the lifecycle method that you're going to be using is component did mount. So there are some predefined method names like component, and as soon as you start typing them, it should give you the list. A lot of these are deprecated now, and there's only a couple of these that still are valid to use. In the slides for class components, it talks about it in a little more detail. The main one that we're going to care about, especially right this second, and the one you're just going to use the most in general, is component did mount. Okay, so you define the method, and then React will call it at different times of the component's life. So thinking of it as like an animal or a person, when the component is born and added to the DOM, component did mount is called. So render will get called for the very first time, and then component did mount will get called. React does this all behind the scenes. So we can see this effect if we put a console log in here. And I'll put another console log in render. Right, there is an old lifecycle method. Try not to clog your brain with this because I'm just telling you in case you run across it, called component will mount, which got called before the render method got called initially. That is no longer acceptable to use. It's deprecated. It still works in React 16, but they're taking it out with the next major version change. So there's no point in getting used to using it. And there's very little point to actually needing it anyways. Because as you're going to soon find out, the constructor, like in any class, gets called before render does. So remember, if you have a constructor, that's the first thing that's always going to happen. And we'll come back to the constructor in a minute, though. So if we take a look at what's actually going on here, we can see render called, and we see our props output from the render method as well. And then we see our console log from the component did mount. Once again, these are called lifecycle methods. Although it's not exactly the same, a lot of people like to think of component did mount as kind of like your document.ready from jQuery. Okay? Similar concepts, different approach, I guess. But you use document.ready to wait till all your DOM loaded, and then you added your click handlers or whatever you did in your document.ready. This is kind of the same thing. Render is called, this gets added to the DOM, and then component did mount gets called. Right? One of the most common things you'll be doing in component did mount is like calling your server to get data. Or making an API call to get data that you can then populate your component with. As probably the most common use of component did mount. But for any reason, if you need to do any action when your component is first added to the screen, anything at all, you do it in component did mount. All right, yes, sir.
So is component did mount and render just blank declarations within React?
You mean in the actual original component definition?
Yeah, I just saw blank.
Probably not. They probably check to see if they're defined before trying to call them, I would imagine.
Okay. We just keep overriding it, so I thought it might just be a blank.
Yeah, no, I don't think it's overriding anything. I think that we're defining them here, but at certain points, like, the constructor is called, then render method's called, and then it probably does a check to see if component did mount is defined. If it is, then it calls it. If I have to guess, which I do, I've never actually looked at the code and see how it actually works under the hood, but. Just to me, it would seem a little pointless to have shell functions defined in the original component.
I thought it's more just like a template that they would call later, then the code said like run render and then run component did mount.
Yeah, I mean there's a function that handles rendering a component that after it calls render the first time, calls component did mount. When any updates are happen, then it will call render again. And then there's other lifecycle methods that we'll talk about very shortly that are called throughout the life of the component. So there's some type of controller thing that's keeping track of all that and calling stuff at the right time. It's probably actually all built into the actual component class itself. All right, so lifecycle methods. If you ever need a lifecycle method, if you need to know when a component mounted and you need to do something one time, you need a lifecycle method. Okay, you got to be careful calling functions inside of a functional component because you can easily create infinite loops and stuff. And we'll talk about that more in a minute too, because we can even run into that here. But if you need a one-time action when the component is first added to the DOM, or if you need to know every time the component updates, you need to do something, or when the component leaves the screen, you need to do something, you need a lifecycle method. Therefore, you need a class component. And so that's one of the determining factors of knowing whether to use a functional component or a class component, if you need a lifecycle method. The next thing that class components could do, and that you need to ask yourself whenever you're making a new component, if you need it or not, is state. Okay? So let's write a little bit of code, and then we'll talk about what state really is. So to create state in your components, you need a constructor method for the moment. I will show you guys down the road how to do it without the constructor method, but we'll start the original way first. So constructor. Now, with the constructor, whenever a new instance of your class is created, remember this props object has to come from somewhere. So when they instantiate a new version of your component, they pass the props object to it. So since we've added this constructor, now we've interrupted that creation flow, we have to intercept the props and then pass it up to the components constructor, the parent class's constructor. And that's why I spent a little time yesterday talking about all this. This isn't because of the way React works. This is just the way the class structure works in JavaScript. All right, and then to create state, we say this dot state equals an object. Okay, state is just an object. It's an object of data that is potentially going to change during the life of your component. And if that data changes, then the render method is called again to update the DOM to show you that change in data. So to start, we will put a message property in here. The constructor is the only place where you ever set the state. Okay, you will never say this dot state equals anything anywhere else in the component. Okay, it has to be changed through a process. We'll talk about that very shortly. And when you are using state in your component, you need to set all the properties that you're going to use in state, set them to some kind of initial value. Even if it's null, an empty array, an empty string, whatever the case may be. Any property you're going to use in state should be set to initial values here. This will help you avoid errors in your render method. It also ensures that when pieces of the state update, that the component updates properly. Because if you don't predefine them here, sometimes you get issues with it re-rendering when data is added to the state object that wasn't originally there. All right, so before we talk about changing the state, talk about using the state. So the whole point of state is that it's going to change. And when it changes, you want to see that change reflected on the screen. So you only store stuff in state that usually you're displaying to the screen in some way, shape, or form, or is controlling what is being shown on the screen in some way, shape, or form. So let's update our render method. I'm going to cut out this h1, do parentheses, div, and put the h1 back inside. And then below that, I'm going to put an h2. And I'm going to say the state is, and then we use values from the state the same way we use values from props, where state is just an object. Okay? It feels like it has some kind of magical thing, but it really isn't. It's still just an object. So if we want to display information from state, we use our JavaScript expression, curly brackets, and then we say this dot state dot whatever. In this case, we want to display the message we have in state. So if we save this and look at it, everything worked properly. You see the state is, this is the original state, right? So we've used state. But like I said, the whole benefit of it is to be able to change it and to see that update appear on the screen. Because once render is called, it's built the DOM and nothing's changing. In order to change anything, render has to be called again, and the information it's displaying would need to change, otherwise you wouldn't notice the difference. So to change the state, there is a built-in method that handles it for us. And there's a couple reasons for that. So let's, after the component mounts, so inside a component did mount, let's change the message inside of state. So we could say, we call this dot set state. Right? Set state is a method that is defined up in the original component base class. Okay? Set state in its simplest form, and the way we're going to talk about it for the moment, takes an object. And then you tell it which properties in state you want it to change and what you want those new values to be. So we want to change the message property and update it to a new message. So all of this is going to happen so fast, you're not going to actually see it change. You're going to see the end result, but you're not going to see it actually change. But what you should see when you look at your page, you should see the message of after it has been changed. So remember when we just looked at it, we saw that it said this is the original state. But after we add this set state call inside a component did mount, I said it happens so fast, you don't even see it flicker or anything. So there's a couple different ways where we can actually see the effects of calling set state. One is to use some type of click event. And we'll get there. But another way is, how can you delay something happening in JavaScript? Set timeout. Okay? So just for fun, and just so we can see this actually happen, let's actually add a set timeout inside a component did mount. So we'll say set timeout. And very importantly, we need to use a wrap it in a fat arrow function. And we'll tell it to wait, I don't know, 4 seconds. And then inside the fat arrow function, we'll move our set state call. Okay, so now what you should see when the page first loads, you should see the original message. And then after about 4 seconds or however many milliseconds you set your set timeout to, you should see it change. Okay? Four seconds is a long time. I'm starting to get nervous. So this is the original state. The state has changed. Also notice that some console log action happened when it changed because our render method got called again, and therefore we see the console logs from the render method. So state is like a snapshot in time. Okay, in the slides, it equates it to like a movie. Some people could resonate with this, some people cannot. But I'm going to push ahead on it anyways. So everybody here knows that a movie is actually made up of a lot of still pictures that are just shown next to each other really fast that create the illusion of motion, right? Everyone knows that, at least on some base level. Okay? State is like a snapshot. This is what your component is displaying right now. Each time the state changes, it updates and displays something new. Okay? So like I said, you kind of think of it like a frame in a movie. Realistically, it's just an object holding data, and when that data changes, the render method is recalled and displays the new data. In the beginning, you're going to want to store everything in state. As time goes on, you'll realize you probably don't need to store as many things in state as you initially think you do. But in the learning process, you're not going to hurt anything by throwing extra crap in state. Everybody does it. If you're unsure, just put it in state. But the actual rule of thumb is any information that is going to change that you're displaying to the user needs to be stored in state. So let's add another thing into state. Let's add a color property. And set it to whatever valid CSS color you want. And then below our other H2, let's display the color. Just the text for now. We don't need to do anything fancy with it. So I'll throw down another H2 down here, and I'll say the color is, and then this dot state. What are you doing? This dot state dot color. And then I want you to watch what happens to color when the state updates. So load your app, wait your 2 to 4 second, whatever you set your time to, and watch the color property. What happens to it? Nothing. So original state has changed. Hot pink did not change. Okay? The reason I point this out is because when we called set state, we passed it an object that only has a message property. Set state is smart enough to only update the property that you tell it to. Okay, so if you have a whole bunch of state and you only need to update specific properties, set state can handle that. That's the way it's designed. So one other cool thing we could do with it is let's add one more property to state. And we'll call it time. And we'll get the current time. How do you get the current time in JavaScript? The date object, right? Even if you don't know the exact method, you know, there's a date object, right? So we say new date, and then we'll do to local time string. Okay, that will give us a printout, hours, minutes, seconds, AM or PM. Right, whatever the current time is when that function ran. All right, and then back down in our render method, let's, between our H1 and our H2s, let's throw another H1 in here. Curly brackets, this dot state dot time. And then we should be able to see the time. Okay, so we can see it's 1:25 and 58. About lunchtime, we're really close. But since we're storing the time inside of state, theoretically, if we updated the state, the time should change, right? We should be able to see the time actually tick by. We can make a rudimentary clock out of this. So how often does the time change? Every second. I mean, that was kind of a very philosophical question. But in general, to the degree that it matters to us, every second, okay? Because, I mean, the real answer only displays down 2 seconds, so we would only notice a difference every 1 second. So if we want to do something repeatedly every 1 second in JavaScript, how can we do that? Set interval. Yeah, set interval. So what we could do, inside of our component did mount again, we could add some more code in here. We do set interval. Give it a fat arrow function again. And we will talk about why we have to use a fat arrow function here after lunch. And then we want set interval to run once every second. So every 1,000 milliseconds. And then in our callback function, we want to call this dot set state. We'll pass it an object of the things we want to update in state. We want to update the time. And we want to set it to a new date dot to local, the exact same thing we did before, locale time string. That's a method we got to call it. Okay, so every 1 second, call set state, and then get the new current time of when it was called. Okay, every time the state changes, the render method will be called again, and it will display the new time. And if you notice, not only is your clock changing, but this still happens. Your clock updating doesn't interfere with the other calling, updating the state. Okay? They all happen independent of each other. So when we come back from lunch, just having a problem? Okay, good. When we come back from lunch, we'll continue to dive down this rabbit hole of state. And we'll also talk about some event listeners, like how to handle clicks, stuff like that. We'll talk about why we needed a fat arrow function here, why we couldn't just use a regular function, which will also tie into the event listener thing, and then we'll also focus a little bit more on lifecycle methods too. Okay? Guys, enjoy your lunch. I'll see you back about 2:30.